大家好，我是克里斯博士. I'm Dr. Chris, and I'm here with Jocelyn. Jocelyn, how old are you?
8.
8. And we're going to do some experiments today. But first, I want to talk about why we're all at home and not in school. Do you know why? Yeah? Is it because of the virus? Yes. So the virus, sometimes called coronavirus, is actually a family of viruses. Some of the viruses in the coronavirus family are SARS, MERS, and the one that we're experiencing now is called SARS-CoV-2. And when that virus gets into your body, then you have a disease called COVID-19, and it can be very deadly. There's almost 1.5 million people in the world that have COVID-19, and many people have died, and that's very sad. But we can help. Do you want to know what we can do to help? Yeah, we'll talk about that today. Now, first, I want to tell you that I'm a scientist, but the kind of science that I do doesn't really help solve the COVID-19 problem because I'm a physicist. So I want to tell you about the special scientists that work to help solve the COVID-19 crisis. The first is an epidemiologist. And an epidemiologist is a scientist that uses math and biology and chemistry and other sorts of sciences to study how diseases spread in the public. So how they go from one person to another person. And they're the ones that can give us recommendations about what we can do, whether we should stay at home, whether it's safe to go outside, whether we need to wear a mask. That's what epidemiologists do. The other kind of scientists is a virologist. A virologist is a biologist who studies very, very small things like viruses, and they can help us understand how we can make vaccines to get better when we have diseases such as COVID-19. So the epidemiologists and the virologists are the scientists that can help us when we're trying to solve this problem. But for the rest of us, there are things that we can do to help as well. Now, the first thing that I want to talk about is washing our hands. But before we do that, since we're all at home and we need to continue our learning, we're going to do an experiment. You want to do that? Okay. So for this experiment, we need a bottle of water. You have your bottle of water? Good. And we need some straws. Okay. And the scissors we're going to use to cut our straws. And then we have some paper clips here. And the paper clips you're going to use as weights to pull the straws down. So the first step is to take one of the straws and bend it back. And then you take your scissors and you're going to cut part of the straw, both sides the same way. There's yours. There's mine. Does everyone have their straw cut? Now you want to take a paper clip and you're going to just open it up a little bit. Just bend it right in the middle. And you're going to stick those ends of the paper clip into the straw. You might need to squeeze the paper clip a little bit. It's nice in there, nice and snug, so it's not going to fall out. And then the paper clip back as well. So that's what mine looks like. There we go. Squeeze this. It's a little bit small. Okay, good. Now we're going to open up our water. What do you think is going to happen when we put this into the water?
It
Sink
will
or float?
float.
Float. So if we put that in the water, it'll float there. Now, if we add more weight to that, do you think we can get it to sink? Use one of these paper clips and see if you can fish out your... If you ever get your paper clip and straw stuck, you can make a little fishing hook and fish it out. Now what we're going to do is we're going to add another paper clip on, so it's hanging off. And this makes it heavier. And then maybe add another one. I think mine's pretty heavy, because see how your straw is a little bit longer than mine? So depending on how much you cut your straw, you may need more or less paper clips. So you'll put the second one on there, the yellow one. Very good. Now, when we drop that in, let's see what happens. Okay. I think this might work. Now, put that lid back on tight. Here's what I want you to do. I want you to squeeze the bottom. Okay. Okay. Isn't that neat? I have to squeeze mine extra hard. There you go. Now, here's some things that you can do if it's not working properly. If you need to squeeze it really, really hard, then you might need to add more weight to your paper clips by making it longer. And if it already sinks, then you need to remove paper clips. Has anyone got it to work? Let's have a look. Good. I think Alyssa has it working. That's it. Yeah, very good. You change the pressure, and that's what forces the water up. Yeah. It's kind of like how a submarine works. Changes the pressure, and it goes underwater, and you can change the air pressure and make it rise up. Okay, so I want to talk a little bit about how we can help solve the COVID-19 crisis. Us, the ones that have to stay at home. So if you have to go outside, when you come home, or even during any time before you eat or after you use the toilet, you need to do what? Wash your hands. Do you know how to wash your hands? Yeah?
Yeah.
So we don't have a sink here, so we're going to demonstrate with dry hands. So what's the first step? Imagine we're at a sink. Going to use water, yeah. So we get our hands wet, and then we have to lather the soap on our hands. So soap is what kills the COVID-19 virus, and it does that by breaking it down. You know how if you get some food on your hands, maybe some greasy food, and then you use water and it doesn't come off, but if you add soap, it breaks down the fats and all the grease of that food. And that's exactly what soap does to the virus. It breaks it apart, and the virus just falls apart. And that's why we use soap. And we lather up But if we do that, then only our palms get soapy. So we have to do the backs. And one thing I always forget is my fingernails. So you can rub the soap into your palm with your fingernails, like that. But we miss between our fingers, so we have to go like this. And then we missed our thumbs too. So we have to push our thumbs. And then you've spread all of that soap and you've scrubbed it, and all that soap has broken apart the virus. And now we rinse it all off with some more water. Now, if you don't know if you've done it long enough, then what you can do is you can count to 20, or you can sing a song. I like to sing Happy Birthday. What's your favorite song? Do you sing Happy Birthday when you wash your hands?
No, when our teacher tells us to sing Happy Birthday twice.
Happy Birthday twice. Are you a fast singer? I sing slow. Happy birthday. Yes. Very good. Okay, so now we know how to wash our hands. I want to do a little experiment with soap and water. Let's move some of this stuff away. Good. Let's leave those just to the side. I like the way they look. So for this experiment, we need some pepper and some washing up liquid, some soap. We're using dishwashing liquid, and we need some bowls, and we need some water. Okay, so first what we're going to do is we're going to pour a little bit of water. Careful, I'm going to pour some water in yours. Very good. And then the second thing we're going to do is we're going to open up our pepper. You're going to grind a little. I'll show you how much. And some pepper. Turn it the other way. There you go. That's good. I think it'll look a lot cooler if we add more. We'll add some more to yours. And some more of mine. Now, if you look closely at your pepper, you can see that some of it is just sitting on the floating. And that pepper is not even really touching the water. There's like a little thin space between it. It's just sitting there because the pepper is kind of afraid of the water. When it gets wet, then the water covers the pepper and it sinks to the bottom. So that's why you see some of the pepper is already sunk to the bottom. Yeah, but most of it will just float on top because it's afraid of the water. Now, when you add a little bit of soap to the water, it's going to spread out in a layer on top of the water. So let's see what happens. Put a little bit of washing up liquid just on your finger, just a little bit like that. And you're just going to touch. Isn't that neat? Now, what happened was the soap, it spread out across the water. You can wipe that soap off your fingers. Luckily, it's soap, so now your fingers are clean. There you go. Dry your hand off. So the soap spread out across the water, and as it did so, it pushed the pepper away. So do you think that if we put more pepper in and tried it again, would it work? We would need clean water because now there's already soap on top of the water. So if we put more pepper on, see how it's just, most of it's now just sinking. Yeah, it sinks now. It has that layer of soap now, that can attach to the pepper and make it all sink to the bottom. That is what I call the scared pepper experiment. Okay, let's set these aside. I think we still need the soap. We're going to still use the soap. And so we can wash our hands and we can stay inside. And when we go outside, there's something else we have to do. We have to keep our distance from people, because when somebody coughs or when they sneeze, then the virus is in the droplets of water in the saliva in our mouths. And when we cough, they get spread out all over the place. But they can only go so far, so that's why we space ourselves apart. And I'm going to show you what that looks like with a little demonstration using these. Do you know what these are? Dominoes. What can you do with dominoes?
You could build them.
Yeah, build them. You can also make a line of them. Now, these dominoes are like us, the people. And when one person gets sick, they can make the other people sick in a line of dominoes like that. But what normally happens is we see more than one person. We might see two people. And then those people might go off, and they might meet two more people. And that person might see two more people. And if each person sees two people, then it will spread very, very quickly through the whole of the population. And that's not good. See? But look at that. One sick person might be able to infect everyone. So what can we do?
Spread away.
Spread away, yeah. So if we have a look here, these people are spread far apart. And one person might say, hey,
That's
would
not
you?
road.
Yeah, that's not very far apart. So if we hit that, what would happen? Everyone would get sick. So maybe this person, these two people say, we're going to stay at home. And that person goes outside and gets a couple of people sick. But all the other people that might have been sick are no longer sick because these people stayed at home. That's what's called social distancing. Let's see it one more time with a lot of people. Set up our dominoes. All of these people could potentially get sick. Yeah. Now, if this person decided they're going to stay at home, not everyone gets sick. So that's why it's good to stay at home, because we can help stop the spread of the coronavirus. Okay. Now, let's do another fun experiment. Can you help me put these away? Thank you. I always like to clean up my messes. What about you? Sometimes? we go. Okay. Let's do another fun one.
Da.
Okay. Very good. Take some of your colors, and we're going to make a little boat. So which color do you want your boat to be? I'm going to take a white one, and color it yourself, or take a different color. Okay. Now you're going to make a little boat, and so we're going to draw a little something that might sit in water. Maybe a fish, or some other sea creature, maybe. I'm going to draw a boat. Not too big though. Just about the size of the palm of your hand. There's my boat. What's yours?
A rock.
A rock. A rock's going to sink to the bottom. Okay. What color is it going to be? Is it going to be like a rock that has like fish and stuff on it? Like a rock from the coral reef? I'm going to have a pink boat. Let's see. Does everyone have their container?
Yes.
Everyone's drawing. Let's wait for everyone to draw. You got a little fish there. Very good. Very good. I'm going to fill this with water. Fill that with water.
Isn't that what we tried?
Well, we're going to take our thing that we drew, and we're going to set it on top of the water. And if we set it very gently on top of the water, then it's going to be like the pepper. And it's going to be afraid of that water and sit nice and on top of the water. So cut out your shape. Now I have a little boat. Jocelyn has some rocks. Now set very gently, set it on the, oh, that's perfect. Okay, now we're going to do the same thing we did before. We're going to see if we can see the same effect. Oh, it's stuck to the side. Oh no, it went under. You got yours to run away?
Yeah.
Mine got underwater. So what happens is if you get your floating thing wet, then it's not going to sit on the surface anymore and it won't be able to run away, pushing your boat or your rock or your fish away. Did everyone get it to work? Let's pause for a minute and we'll see what everyone thinks and see if they have some questions. Remember, you can only get it to work once. Get it to work? Did it work for you?
Experiment that they did it good.
Yeah, you did.
Yeah, I know. If you put a paper clip, you put a paper underneath and then
Okay, this one's called the drinking fountain. And we're going to find the material here. The bowl. So let's have a look at what we have here. Maybe 2 cups. Okay, so straws, and we have our blue tack, and the water. So we have our bottle, which will form our drinking fountain, the straws, and we don't want to make a mess, so we're going to have the water go into a bowl. And if you need some help propping up your drinking fountain, we'll use some cups. And one of the most important things is just something sharp. So I have a screw here, and also we'll use maybe the tip of a pen. So that part you'll have to get your mom and dad to help you with, because it's going to be difficult to poke the hole. But so I will poke the hole, and then you'll do the rest. So we're going to just poke a hole in the bottom of the plastic bottle. Everyone got their screw? Ask mom or dad to help you poke a hole. Now you don't want to make the hole too big. You just want it just big enough for a straw to fit in. So I started with a little hole. You want to try it? If it's a flimsy plastic, you might be able to get it to work. Push it down right in the middle. Get it? Got a little mark there. Yeah. I'll start in that same spot. There we go. And I'm going to use the pen to make the hole bigger, because the pen's nice and round. Get that pen there, wiggle it around. Go. Try. Get mom and dad help with that. Just big enough so that the straw will fit in there. No? Now see if you can get the long end of the straw into that hole. Oh, so quick. Now, oh, nice one. Funny looking, isn't it? We're going to take some blue tack, and we're going to make a seal, because water is still going to squeak out of there, isn't it? Yeah. So take some of that blue tack and wrap it around. Make a nice tight seal. Just wrap it around. You might need more than one piece of blue tack. If you need some more. Did you get it all the way around? You need a little bit more? No? You're doing a great job, Justin. Very good. Now we're going to fill it with water, but what's going to happen if we fill it with water?
It'll go out.
Yeah, it'll go out. So you put it there, yeah. Yeah, yours is pretty good. Yours is pretty good. I'm going to use a cup instead of a cup, just so it's up a little bit higher. You could do that if you like, but yours is in a good spot. Okay. All right. Good. So this can be tricky too.
Very sticky.
Oh, dear, right on top of this bowl. I'll put it close for you. Okay, put that cap on nice and tight. Whoa. That's all right. If you squeeze it, you'll get some water to come out of that, through the cracks in there. But now there's no water coming out. There's no water coming in line. Very good. Now, how can we get the water to come out, do you think? Maybe squeezing it, but if we go like this, just open it just a little bit at a time. Open, close. We're just filling up. The more you open the top, the more air can get in, and the air pressure will be able to push down the water, and gravity will pull it down the straw, out the straw. On, off, on, off.
Mine is not too much.
Yours is full. Oh, but now what? Why doesn't it fill up coming out? Because the straw on the inside is no longer in the water. So in a real drinking fountain, you need a constant source of water. This is a big watery mess. Can I see some other ones here? Let me put my sound on and see if I can hear what others will say. Does everyone have one? Very good. Oh, there's a very, very good one.
That's Michael.
Michael, you have a very good drinking fountain. Oh, it works perfectly. Oh, you could squeeze it. Yeah, very good. So if you squeeze it, then that will change the air pressure and force the water out.
That's
Can you get it to suck the water like that? Anson had his. Very good. Oh, I like how the background.
We can't see our photo.
It's a magic fountain.
Your
Very good.
magic fountain. That's because it reached the bottom of it. There you go.
And this one, your fountain. Works very well.
You got a magic wand because no one can see your bottle. Okay.
Oh, it's strong. Like if you have a straw, how do you get water to come up the straw into your mouth? You suck on it. Yeah. And how do you do that? You're changing the air pressure inside of your mouth. And that will force the water or whatever's in your cup up into your mouth. Very cool. Okay, we're going to do another fun building experiment, but we just need to clean up this mess first. So that's going to take just a second. I'll put my earbuds in so I can hear if there's any questions while we set up.
Yeah.
Cardboard. And we have scissors. We need scissors. You put your scissors in front there. Okay. Could we use that? So we're going to build some cars. Does that sound hard? Building a car? Maybe? So a car has an axle that allows the wheels to turn. So we're going to use these two things to make something that can turn. So we put the barbecue skewer, food skewer, into the straw. Then we can attach things to the straw and this will still turn. Yeah? Does that make sense? Okay, so we want to be able to attach some wheels to the end of these skewers here. And we're going to put it through the straw. That's a really wide, to make it more difficult to make. So let's cut that in half. Cut your straw in half, right in half. Now, if you're following along at home, then there's lots of different ways that you can do this. And I'll just mention the most important part. So you can make your straw as long or as short as you want, but when you stick the barbecue skewer in, you have to have parts of it sticking out. Yeah? Very good. Okay, so that's one set of wheels, and this would be the second set of wheels. Just like that. And we'll put the car on here, attach the car to here, and then the wheels can move separately. Very good. Okay, so let's set that aside. That's the most important part. Got to get that working first. The skewer has to be able to spin inside of the straw. Okay. Now, there's lots of things that you can use to make wheels as well. So maybe you could use like cups. They're round. Anything round? Cut the bottom. Yeah. You could. You can use cardboard even. So I'm going to show you how to do it using cardboard. And how many wheels on a car?
4.
4. So have a go at trying to trace out a circle. And make sure you use the space on your cardboard wisely. So start up in the corner. And you want to make 4 wheels. Okay. Now we have to cut out our wheels. So that might take a little while. Here's a little trick I know. You cut the square out first around it. Cut it out, you know, not so good at the beginning. And then it's much easier to cut away the parts that are too big.
Scissors are a little bit small.
Scissors are too small? You want some help? You trade? Just like you have thick cardboard too. Here, have a go at this cardboard. I'll try out your cardboard. Yeah, you have thick cardboard. Yeah, it makes it more difficult to cut. On a car have to be the same size?
No.
No? No, they don't.
Yes. Yes.
Yes? Most cars have the same size wheels, but some cars don't. Yeah?
Dr.
Right
Chris,
with the
I'm
left
a
hand?
left-handed too. So one my friend taking that one.
Both hands. Ah, that has a long and funny name. So we have 4 wheels. You want your brown wheels back? I have my white wheels. Nice and round. You can see how they turn. Special thing about a wheel is that it only touches the ground at one point. Okay, so now we're going to attach our wheels to our axles. And the way I'm going to do it is first take one of my skewers out and poke a hole right in the middle. Now, it should be right in the middle. And watch out, because this is sharp. And it's going to go through, and you don't want your fingers on the other side when that goes through. Very good. I lost the sharpness of my skewer. Okay. Now we're going to attach the 4 wheels to the skewers. Now, here's the trick. Put it right on. Put it right on. Okay. Very good. But make sure you get your straw back on there before you attach the other one. There we go. And now look at this. You can hold on to this and have your car move.
It's bumpy
Yeah, it's bumpy. Why is that?
because it's cardboard.
Yeah, because it's cardboard. Would you buy a car made of cardboard wheels?
No.
No, me neither. So if you're at home and you're making your car and you're on this step and you poked a hole that's maybe a bit too big and the wheel doesn't stay on there nice and straight, then you can use some tape or some glue to get it to stay on.
This one that is very loose.
Do you want me to try the tape to make it stay on there nice and
I thought it was
straight?
like saying
Might need some more tape. Do you know what's on tape to make it sticky? What's on tape?
like glue
Glue, yeah. Do what?
to stay on.
Yeah, it's dry. Okay. We do the same thing with the other ones? You're ahead of me. Very good.
This one is much more better than that one.
Yeah.
This will stay good.
Okay. Now we have a car, right?
Yeah,
What do we need?
the top bit.
The top bit, yeah. Body of the car. I'll cut you off one. There you go. Is it long enough? Oh, is it too short? Make sure the wheels don't touch each other. Yeah.
I was thinking of doing that.
Yeah, that's good. Now I'm going to tape my.
I might do another one.
You want another one? Go. There we go. Yeah. Because that way it might be a bit more difficult to tape.
This
It's hard work, isn't it? Making a car.
can you stick it on?
Stuck one on just like that on the edge.
Whoa. These car stuff are so hard. They're wiggly around.
Let's have a look and see how everyone's doing at home. Oh, very good. I see one card. You've done a great job. Oh, look. Look at that one. The first one. Some more, just to make sure. That's a good idea. That's my card. And then I'm going to blow up the balloon. And I hope that it's going to push my car. Do you think a balloon could do that? No? Okay, just very gently. The balloon across the end. So, for those at home, there are many different ways you could do it. But what I'm going to do is tape the balloon right here on the end. And you don't want to tape it too tight because you want air to go in and air to come out. Get mom or dad to help. I'm just going to do it nice and loose on there. Then you won't be able to blow up the balloon. It's hard enough to blow up a balloon, but now you have to blow up a balloon while it's attached to a car. Blow really hard. Watch this one. And allow people to ask questions. Oh, 2 balloons. Good. It flips over. Yeah. What will happen if I let go? It'll fly away, yeah. Because the air in the balloon is going to be pushed out. And so that force on the air has an opposite force on the balloon. Have any questions from the kids at home? Do you have any questions? Hold up. To join me in the lab to do more experiments and to learn about science and all the things in the world, some of which we can't see with our eyes, but things like forces we can experiment with and find out how they work in the lab. We'll say bye, everyone. You say bye with me, Jocelyn? Bye.
Bye, Dr. Chris. Bye.